This is our animal behavior lab. Changes in external environments cause organisms to respond through psychological and behavioral actions. Behavioral is the nervous system's response to stimulus and is then carried out by the hormonal system, muscular systems, or chemical responses.
In this lab, we will be conducting an experiment testing a termite's response to a change in orientation and elevation. We are trying to determine the fixed action pattern of a termite, or its taxis. A taxis is a voluntary movement towards a stimuli, while a fixed action pattern is where the movement is a characteristic innate behavior. Our null hypothesis is that termites will not migrate based on elevation, therefore are not affected by a change in elevation. First, you need to collect your organisms you will be testing on. You can use organisms such as ants, which you can find outside.
Or your teacher can supply you with organisms such as termites. We will be using 2 joint petri dishes in this experiment. Take 2 circular filter paper and tape them into the bottom of each, like so. Then, place a small piece of tape over the bridge in the middle so that the termites will be able to move.
Then, you have to collect your organisms and place 5 on each side.
This lab was designed for your own creativity. In our particular lab, we're testing the movement of the termites based on elevation, but your variables can be testing moisture and how they respond to that, or temperature, and have one part of the petri dish be hot and one be cold. It's up to you. Next, we have to put the termites on the gyro twister. Don't forget to plug it in! Set it to a desired elevation.
Once you have reached the desired elevation and orientation, allow yourself to record the termites' movements every 30 seconds for 10 minutes. Make sure that you are writing all of this down because it will be very important when discussing in your results section. Okay, so for this lab, you're going to be finding chi-squared. Chi-squared is the percentage value supporting the null hypothesis. The null hypothesis for this particular experiment is that there will be no difference between the number of organisms per plane. So, what you're going to do is you're going to take the observed, which will be the numbers you have on the graph, minus the number of expected. And considering you have 10 organisms and 2 plates, you will expect 5 organisms to be on each side. You're going to square that and divide it by the expected. So in this case, we will take the numbers 7 and 3. And we're going to do, we'll just take the number of pi, for example. And we'll take the number observed, which was 7, minus the expected, which was 5. square that divided by 5. And that will be our chi-squared value. And then we're going to do is we're going to calculate the chi-squared for every single data point, and then we're going to add them together to find on the graph, to find the number, or to find the percentage that supports the null hypothesis. For our results section, as you can see here, our null hypothesis is not supported. Now, basically what we're going to do is we're going to calculate our chi-squared value. And how you're going to do that is the formula is observed minus expected squared over expected. So in this case, we're going to take 5 minus 5 squared over 5, which is 0, I think. But then, you're going to calculate the chi-squared value for all of these 20 data points. And you're going to add them together. And then, when you go to look on your chi-squared graph, what you're going to do is you're going to take 20 and subtract it by 1 to get the degrees of freedom. And now, basically what the degrees of freedom are is on your graph, you're going to look and see the 19th degree of freedom, and then over here you're going to see your chi-squared value. And that will tell you whether there is a 10% chance that it proves the null hypothesis, or there's a 90% chance that it proves the null hypothesis. And basically, what that is saying is that there's if we got 10%, that would mean there was a 90% chance there was a difference between the observed and the expected, which would be disproving our hypothesis. Time to clean up! Dispose of all dead organisms and other materials that your teacher says you will not be keeping. Place the petri dishes in the sink to be washed, and place all other materials that you normally would reuse in the sink to wash. Live organisms should go to your teacher. They should not be thrown out, or put down the drain, or put outside. None of that. Give them to your teacher so they don't destroy the Bella Dixon Math Science Lecture Hall.